Okay, what we're talking about here is sample paper D and going through the various problems that people were experiencing. So first of all, we've got question 1A, and we've got information question which talks about the moduli of numbers and their arguments respectively. And the question basically asks us to find the modulus and argument of uv, of u, and that's dot v, u times v. So straight away, you've got to be reminded of what modulus argument form is. And what modulus argument form is that for a complex number z, we're using the form r open bracket cos theta plus I sine theta. So that's what we're using. Now r is known as the modulus, and the theta is known as the argument. And because of that, when we come to fill this in down here, what is w? Well, w, we were told, has a modulus of 1 and an argument of pi over 2. So when we substitute into the formula here, we get the answer down there. And similarly, we know that the modulus, the r value for the w is 2, and that the argument for the w is pi by 3, and we substitute it into that formula to get that answer there. And then the question quite clearly states that they want us to find the product of these two complex numbers. Now, because the hint in the question was to write it in modulus and argument form, we know that there is a formula which says to find the modulus of a product, then you multiply the two moduluses together. To find the argument of a product, you add the two arguments together. So therefore we've got that, and consequently we can then use this to find the modulus and argument. Now, it was unnecessary to do this line in order to answer the question. Now, this line is technically unnecessary, but at the same time it's just wanted to do an overall explanation of what the problem was about. Okay. So now when we go on to the next part of the problem, it asks us to do this in rectangular form. So here, because it's asking us to do it in rectangular form, how do you work out the modulus when it's division? Well, to work out the modulus when it's a division, you end up dividing the two moduluses. And when you're doing the working out the argument for a division, there is a formula where you do the subtraction. So therefore, we now know that the new modulus for the division version is going to be a half, and we know that the new argument is going to be pi by 6. So therefore, when we substitute it into this formula, complex number is equal to z is equal to r cos theta plus I sine theta, and since we now know that the new modulus is equal to 1/2, the new modulus is equal to 1/2, and the new argument is equal to pi by 6, where there, then we can work out, well, this is going to be 1/2 on the cos of pi by 6 plus I sine pi by 6. So that's how we get that line there. But they didn't ask us that just gets a temp mark. What they asked us to do is get the Cartesian version, the rectangular version. And can I remind you, rectangular form is same as Cartesian form, and modulus and argument form is the same as polar form. So you've got modulus stroke argument form is equivalent to polar, and rectangular form is equivalent to the coordinate form. Which is what we have here. You just use your calculator, 1/2 times cos of pi by 6, or 1/2 times cos of 30 degrees, because don't forget, pi over 6 is the equivalent of 30 degrees. And that's the end of A part 1 and 2. Okay, moving on. To the next part of the problem, we're looking at De Morgan's theorem to prove the identity that cos 3 theta is equal to 4 cos cubed minus 3 cos theta. Look, if this comes up in the exam, which is highly unlikely, getting something right will get you a lot of marks. So the first thing is you have to recognize when they gave you cos 3 theta, when they gave you cos 3 theta, you had to recognize that cos 3 theta, when linked with complex form, can be linked with I sine 3 theta. So when you see the cos 3 theta, you're prompted to think of this. And if you're prompted to think of this, then you're looking at cos theta plus I sine theta. You're looking at De Morgan's theorem in reverse. De Morgan's theorem says if you've got a power of 3, that you can bring it before the theta, the two arguments, and multiply. So therefore you've got to then spot, if you've got 3 in front of theta, you can bring it out and write it as a power. So that's how we proceed with this particular problem. So we've got, reiterating what I just done up there, you end up with this thing. And then what we're going to do is we're going to expand the cos theta plus I sine 3 theta. And we're going to expand using, well, I'll show you here. Basically, we can just multiply it out, or we can use binomial theorem. So it really is up to you. There's 2 ways of doing cos theta multiplied by I sine theta. Just show you. Just try to move this up. So if you've got cos theta, cos 3 theta plus I sine 3 theta, then we know that becomes cos theta plus I sine 3 theta to the power, sorry I didn't mean to put the 3 there, to the power of 3. And then what we do is we're going to expand this. Well, if you want to just get marks and then cut and run, then you can do cos theta plus I sine theta and then cos theta plus I sine theta plus multiply by cos theta plus I sine theta, and then basically expand that out. Just don't make any mistakes. It will take a long time. Or you can use the binomial, and the binomial says that you've got 3c1 and then bracket plus 3c0, then you've got 3c1 bracket plus 3c2 bracket plus 3c3 bracket. Then you need to make reference to the formula book, and if you're looking this up in the formula book, then you're going to the algebra page, and it's on page 20 of your formula book, and basically the second bracket has 0, the first bracket has n, then here it's the n is the number here. So this is what it says in the formula book, it says n, but you have to recognize that the n value is this 3 here. And then once you've established the first pair, then you've got to remember that as you go across, that will go down and this one will go up. So 2 goes down to 1, 1 goes up to 2, this one here goes down to 0, and that 2 goes up to 3. The number that goes in here is going to be the cos, and the number that goes in here is going to be I sine. So it's going to be cos and I sine, it's going to be cos and I sine, and it's going to be cos and I sine. And then once you've done that, it's a case of expanding it. It is a case of expanding it, which is what we're going to see now. So just clear out that, so make it a little bit easier to read. So then you start expanding it, and that's what you get. So 3c0 is equal to 1, cos cubed is equal to cos cubed, I sine to the power of 0, anything to the power of 0 is equal to 1, and then here 3c1 is equal to 3, and you just work your way through it, trying not to make any mistakes. I sine theta all squared is I squared sine squared. You know, I sine theta cubed is I cubed sine cubed. And that is what you have got to do. There's no more explanation in that particular problem. You have to work your way through it. Me going through it isn't going to make any difference to your understanding. You have to make sure you expand it properly, and that you do it neatly, and that you don't make any mistakes. What's I cubed? Well, I cubed is equal to I. How do I know that? Well, let's just do it here. So I'm actually trying to work out this I cubed, which is written there. Let's put a red circle around it so you can see it more clearly. So I need to work out I cubed. So I cubed is equal to I on I on I. Well, that's I squared. And what's special about I squared? Well, I squared is minus 1. So what do you end up with? You end up with minus 1i, which is what we have down here. So once you've got that bit done, in order to finish this problem off, we were asked to focus within the question on finding cos 3 theta. Well, cos 3 theta is a real part. There's no imaginary link to it. So we now know it's going to be equal to this real part plus this real part, because these two parts don't have I in it. So that's why the statement below says comparing real parts only, because that's all we need to do. So then we do that, and once again we have to then work through it. What's sine squared? Well, it's in the formula book, but you should have learnt it. Sine squared is 1 minus cos squared, so therefore I'm going to replace the sine squared by 1 minus cos squared, which is what you're going to see on the next line below, and then we expand it, and then we eventually work out the problem. And that's the end of that part there. And here's remember I squared is equal to -1. Remember I cubed is I on I squared, and because I squared is equal to -1, yeah, but I did it up above anyway. That's the end of that. We'll now move on to the next page. Okay. Now, no one asked for question 2A, 2B and 2C, but I'm going to very quickly whip through it anyway, just for the sake of completeness. You're told that x squared minus 10x plus 20 is to be write it in the form x minus a all squared plus k, and what you do is you expand the right hand side, and then you compare the left hand side with the right hand side. So the completing the square method is not one that I actually favour anymore. So to be totally honest with you, I don't actually favour that anymore, because it involves learning something off by heart, as indeed as method 2, but it's more prone to error. So when you're actually completing the square, in recent years they've actually given you the formula, so therefore all you've got to do is expand it and compare. That makes it sort of somewhat easier. So here you now have, I've expanded the right hand side. I'm now comparing it to the left hand side, and as a consequence of that, I can now see that I've got this thing here. Oops, just a bit on the large side. I've got my minus 2a here is going to be equal to minus 10. And I've got my plus a squared plus k is equal to plus 20. Now that might have been better if I'd done that in a different colour, so I'll just change that. And my plus a squared plus k is equal to plus 20. Consequently, you've now got minus 2a is equal to minus 10. Change the signs. 2a equals 10, divide by 2 to get 5, and I've got my value of a, which I can then substitute into here. So a becomes 5, so a squared becomes 5 squared, plus k equals 20, because 5 squared is equal to 25. I think there's an error here. The 25, I've skipped a line and I've paid a price. Poor form. Sorry if I confused anyone. So the next line really should have read, forget this line here, we've now got 25 plus k is equal to 20, so k is equal to 20 minus 25, so k is equal to minus 5. My apologies. Moving on. We've now got the minimum point is a k, and that is the, why is it a minimum point? Well, with this quadratic is a positive quadratic, so we know that this quadratic is we know that this quadratic is this way up because it's a plus x squared. When it's in the completing the square format, when you extract the minus a, it becomes a plus a, and when you extract the plus k, it remains as a k. So you've got to learn that, and therefore we've already established that a is equal to 5 and that k was minus 5, so therefore we end up with those 2 points. That's the minimum point. This is called the axis of symmetry, the first value, and this is called the minimum value. Why is this the axis of symmetry? Why is it equal to 5? Because if you draw a line here, a symmetry line, it's going through x equals 5. So it's a vertical line, and therefore it's the equation x equals 5. Find the roots of the quadratic equations given your answers in Cert form. Well, there's numerous ways of doing this. The obvious way is to go back to the original question and then just use the quadratic formula. So no one really asked about this, so I don't really think there's any need to do it. Or you can use the question method above. Most people would choose this method here, to be honest. So we'll move on, there's no point. People asked about D. Well, I'll reiterate what I said above. What do we have? We have a positive quadratic, so therefore it's a happy face quadratic. What do we know about this? We know that the minimum point is 5, minus 5. We know the axis of symmetry is that line there, which is a vertical line. If it's a vertical line, it has an equation x equals. What is x equal to? It's x equal to 5. You have to learn that vertical lines are x equal lines, and then we've finished that question. Now it's question 3 down the bottom, which I nearly missed. Just taking a look at the notes here. I think there was 1 or 2 people. No one asked about question A. I'm going to assume that you understand it. I'm a little bit concerned that I might have skipped a few lines here, so I'm just going to very briefly talk about it, taking it from this bit here. That wasn't done particularly neatly, so I'll go and do that again. Okay. So what we're looking at here is we're looking at this set of numbers which are clearly repetitive. 7031 is the repetitive part. So we've got 0.7031 is a recurring decimal, because they said 7031, and it recurs across the cycle 7 to 1, which means we can now write that as 0.7031 plus 0. We've lost 1, 2, 3, 4 digits in the repeating cycle, and then it's repeated again, 7031. What is 7031? Well, it's going to be 7031 divided by 1, and you count how many places there are, 1, 2, 3, 4, which means there's going to be 4 numbers on the bottom, which is 3 zeros. And here, what number goes on top? Well, it's 7031. And then you count, when there's a 1, you count the numbers again, 1, 2, 3, 4, 5, 6, 7, 8. So therefore there has to be 8 numbers on the bottom, so it must be 7 zeros, 1, 2, 3, 4, 5, 6, 7. And you should know or remember that this is a geometric sequence. We now know that this is the first term of the geometric sequence, so therefore there's our A, and we have to ask ourselves, what do we multiply that by? Well, the top gets multiplied by 1, hence the 1 on top. The bottom has got an extra 4 zeros on it, so therefore it's been multiplied by 10 to the power of 4, and then the rest is fairly straightforward. Right, going to the next page. That's question 3, part A. Now, a number of people requested an explanation for B. First of all, go back to the textbook. You have to learn to let Pn equal. You have to learn to write it in that format. If you don't, you're going to get it wrong. and that's just, I'm sad to say, is a memory game. N belongs to the set of natural numbers, so according to the formula book that makes reference to numbers which are going to be 1, 2, 3, 4 going on forever. So therefore the lowest value of n that we're using for this question is n equals 1. So therefore, using proof by induction, we have to show it's true for n is equal to 1. So p of 1 is going to be 7 to the power of 2 times 1 plus 1, which is going to be 7 to the power of 3. 7 to the power 3 is very much, plus 1 is definitely much a calculator, get 344. Divide that by 8 to find it's 43, so then write it as 43 times 8, and therefore you've shown that it's true for n equals 1. It is a factor, 8 is a factor. Now, assume true for n equals k, so therefore what are we assuming true? We're assuming that p of k, when n equals k, that the expression has a factor of 8. 8 will divide into it. So therefore we're assuming this 2 to the k plus 1 has a factor of 8, and so on. Now, getting on to step 3, we have now got to show that this is going to be also true for n equals k plus 1. Now, so what we had, I can't flick to the top of the page very easily, so I'll do the writing here. What we have is we've got p of n is equal to 7 to the 2n plus 1 plus 1. And we're going to be exploring a situation where n is equal to k plus 1. So we're going to have p of k plus 1 is equal to. Now it's best if you go off to one side and do the working out. So n is now equal to k plus 1 plus 1. So we're now going to have 2k. So we're going to have 2k plus 2 plus 1. So we're going to end up with a formula which is 2k plus 3. So let's let you take that in. So we're going to end up with 7 to the power of 2k plus 3 and then plus 1. So when we go down and reveal this, that's what you're going to see. Okay, so that's where we just got to. So now the thing is, we have to make that look like part 2, step 2. We need to make this look like part 2. So the first thing I'm going to do, I do the working out here, then I'll reveal it in a few minutes. That's going to be 7 to the 2k plus 1. That's what I want it to be, because that's what it says here. But it isn't, it's actually plus 3, so I've got to add 2 on. So it's still the same as the line above. Now we know, according to the law of indices, that when we have a plus 2 there, we're using the multiplication law. So that's going to be 2 to the k plus 1 multiplied by 7 to the power of 2 plus 1. Now, so we've got this part of the problem sorted. And now I'm afraid you have to learn a trick. And the trick is, I'm going to multiply this by 7 to the 2. And I've created something. And what I was meant to have a plus 1 there. It's meant to have a plus 1, which I've decided to write there. So, but I've just put this extra term in that shouldn't be here. So now I'm taking it off. Now, if you get stuck on this bit, I wouldn't lose any sleep over it. If you just finish off by saying step 4, proof follows by induction, you're going to get 10 or 11 marks out of 15. If you'd actually written this bit here, And that's what's given you the 10, 11 or 12 marks out of 15. But to carry on, just to show you how it's done, because I'd actually introduced that 7 squared there as a trick, I can now take out 7 squared as a common factor, leave me with 2 to the power of k plus 1 plus 1. And then I've got minus 72 squared, which is 49, plus 1. This is now going to be 49 on p of k, because that is pk. And this thing here is minus 48. 8s go into pk, that's divisible by 8. By step 2, and that's divisible by 8 well, because 8's go into 48 6 times. You can explain that to the examiner, it's not a problem. And that is the end of that part of the problem, and then you say proof follows by induction. Okay, we're now looking at question 4. I'm going to do the working out here and then reveal to make it a little bit simpler for you. We're going all the way back to 2nd and 3rd year and getting a reminder that f of x can also be written as f of x is equal to 2x minus 1, and g of x can be written as 3x squared, but it can also be written as f empty bracket equals 2 empty bracket minus 1, g empty bracket equals 3 empty bracket squared. So what we have now is, when we look at the question is find an expression for g f of x. So we write down here where we've got g f of x, and the first thing we are going to be working out is we're going to be working out f of x. But we know what f of x is. F of x is equal to 2x minus 1. So therefore we can now do g on, well, what is f of x? We've just highlighted it. It's equal to 2x minus 1. So that's done. Now we're going to be doing the g of x. Well, we're not allowed to use the top formula because this formula is only used when we have x. We don't have x, we have x, 2x minus 1, which means we're forced to use the empty bracket method. So the empty bracket method is 3 empty bracket, all to be squared. But what's in that empty bracket? What's in that empty bracket is going to be 2x minus 1. So we put 2x minus 1 in there. And that is the answer. If we stopped there, that is the correct answer. Now I suspect that going on to work this out, so 4x squared minus 2x plus 1 is equal to 4x squared minus 4x plus 1, and substitute that in 3 bracket 4x squared minus 4x plus 1, and then expand it out, 12x squared minus 12x plus 3 is what they're looking for on the back of the book. But I still think if you stop there, you'd get full marks in a real exam. Okay, well that's the end of that part. Let's have a look how that went here. Well, the same thing, but just not without any working out really. That's a more fuller explanation, and indeed I hope that actually helps you. Okay then, so end of that one. Alright then, so moving on, it says verify your answer for g f of x using the value 2. Well, here's the answer from the last page, and what we have here is the function. we're then going to be putting x equals 2 in it. So when we go to the next line, you'll see there's a 2 in it. Using the empty bracket method, empty bracket, empty bracket, empty bracket, putting a 2 in, and then reaching for a calculator, working it out and getting 27. Now, on the right hand side, I'm sorry, I don't think that is as clear. So what we need to do is go back to the previous page and have a look at what F and G. Okay, so this is what we had in the previous page, which we now use the empty bracket on once again. The empty bracket method. And what we're going to do now is we're trying to work out gf of x. So we've got gf of x. So we've got gf of x when x is equal to 2. So we've got gf of 2, and this is what we've got to work out. So how do we do this? Well, we need to work out what f of 2 is. So therefore we're going to be extracting this and working out what f of 2 is. So we've got f empty bracket equals 2 empty bracket minus 1. We put 2 inside it. 2 2's are 4. 4 take 1. The answer's 3. So therefore what have we now got? F of 2 is equal to 3. So therefore this line now becomes g of 3. So now we're going to be using this empty bracket, and this empty bracket is just 3 empty brackets squared. What goes inside this empty bracket is 3. 3 squared is 9. 3 9s are 27. And that's the end of our problem. And so we've now shown it both ways. Well, the first thing you've got to do is you've got to work out what the top is equal to when x is equal to 7. That's the very first thing you've got to do. So when we put x equals 7 in, we're going to get 7 to be squared minus 5 lots of 7 minus 14. And then we're going to get 49 minus 35 minus 14, and the answer is 0. Okay, that's simple enough. And that's the top. Now we're going to work out the bottom, and the bottom is equal to x minus 7. So it's going to be 7 minus 7, and the answer is 0. So this is a bit of all-round revision. So what have I got at the moment? I've got the top divided by the bottom is equal to 0 over 0, and this implies that you have to factorize before you can go any further. Quick reminder, if you substituted in and the answer was 0 over a number, then the limit is equal to 0. If you substituted it in and you had a number on top which was not 0 and a 0 on the bottom, then you say the answer is no limit, it's not defined, or it tends to infinity. But if it's 0 over 0, you have to factorize. And of course, when you factorize, what you'll end up with is an x minus 7 on the bottom and an x minus 7 on the top, which can be cancelled out. When you cancel it out, you then put in didn't mean to do that. Then you put in the limit. Then you've got x tending to 7, so you let x equal 7. So you get to this line, 7 plus 2 is 9, so therefore you say the limit is 9. On this one, what happens when you put infinity in? Well, what do you have on top? On top, you've got n squared plus 9. So if you put infinity in, you get infinity squared plus 9 is equal to infinity. On the bottom, you end up with 2n squared plus 9n, which is 2 lots of infinity squared plus 9 lots of infinity, and whichever way you look at it, it's infinity. So what do you end up with? You end up with top over bottom is equal to infinity over infinity. It's complete rubbish, and you've got to learn that the method for this is divide by the highest power of your variable. In this case the variable is n, so you're dividing top and bottom by the highest power of n, which of course in this case is n squared. The highest power is n squared. So when you do that, n squared divided by n squared is 1. 9 divided by n squared is 9 over n squared. 2n squared divided by n squared is 2. 9n, well, let's do it over here, 9n divided by n squared is 9n over n times n. The n's cancel, so it just becomes 9 over n, which is what we have here. Then what we do is we let n tend to infinity, and because n's on the bottom, 9 over infinity, if we take the 9 over n squared, it's going to be 9 over infinity squared, which is 9 over infinity, and 9 over something very, very large is regarded as 0. And then 9 over infinity, because that's what n is again 9 over something insanely large, is also going to be equal to 0. So that's why those two values are 0, and you're just left with an answer of a half. That's the end of that one. So 5 part B. This question says you've got a function g, so let's have a look at the function g. The function g is g double dot x becomes x squared minus 5. So we can write that as g bracket x is equal to x squared minus 5, and we can also write that as g empty bracket is equal to empty bracket squared minus 5. Not that this is particularly relevant to this problem. In this problem we're looking for the inverse, so we're going to be using the middle version. So we've got g of x is equal to x squared minus 5, and when we are looking for an inverse we let the value y equal to g of x. So therefore we've got x squared minus 5 is equal to g of x. So now we've got x squared minus 5 is equal to y, and then we isolate the value of x. So x squared is equal to y plus 5, and then x is equal to the square root of y plus 5, but don't forget it's plus or minus. Now this question, finishing off, we're going to choose the plus value, so I'll just do it over here. So we're going to choose the plus value, so it's going to be the square root of y plus x, and then you've got to remember the trick. You now say, well, the inverse function of x is equal to the square root of say plus 5 there. It's going to be the square root of, and the y gets changed back into an x, plus 5. Now the reason why this question is flawed is because it doesn't work. They ask you to find an inverse function where x belongs to the set of real numbers. So if we were to draw this function for this particular problem, then we end up with a function which looks like this. Now for a function to have an inverse, it must actually be both injective and it must be surjective. And injective means it has to pass the horizontal line test, and this does not pass the horizontal line test because there's two sides to it. So the only way this can pass the horizontal line test is if I rub part of it out. So if I choose to rub out, say, this section of it, and if I choose to rub out this section of it, then I'm only considering the x values which are r plus, not r. So the question is wrong. But if it being r plus, then this question would be absolutely fine. Still a good revision question, just ever so slightly flawed. Okay, part 2. We have to show that g on g minus 1 of x is equal to x. So what I've done is I've written both functions out from above. I'm now doing the empty bracket version of each one. So g empty bracket is equal to empty bracket squared minus 5, and g minus 1 empty bracket is equal to the square root of empty bracket plus 5. I'm then going to write out the question, which is g on g minus 1 of x. So the first thing you've got to work out is this bit, because this is the bit where the function is on the x. And we know what that answer is straight away, because it's up here. So therefore we're going to be replacing that red box by the red box up in the top right hand corner. So therefore this now becomes g open bracket on the square root of x plus 5. Now because this thing here is not an x, it means we're forced to use the empty bracket method. When it's an x, we can use the formula above the green highlighter section, but when it's not an x, we have to use the empty bracket method. So therefore what we have now, that this g bracket is in actual fact bracket to be squared minus 5. So then we put inside the bracket the x plus 5. Of course, a square on a square root, they cancel each other out, so that ends up as being x plus 5, the minus 5 there, which then leads us to the answer what we were looking for. This is the proof question, so you have to show every single line of working out. So we're now going to move on to question 6. Okay. Integrate. Before you integrate all of it, you must look at each individual bit. Can I integrate x cubed? Yes. Put the power up 1, divide by the new power. So let's remind us of the mantra. When we're integrating powers of x, when we're integrating powers of x with respect to x, the actual method is put power up 1 and then divide by the new power. Then divide by the new power. So I can do it for that one, I can do it for that one, I can do it for that one. When you integrate a constant, you just put a letter in, so I can do that one. And here's the one that could cause us problems. And it's one that you ought to be aware of. It's in the formula book. And the integral of a 1 over x is quite simply ln x. Now the most common mistake on this is to actually say, oh, you can't do the integral of 1 over x, it's going to be the integral of x to the power of minus 1. And of course, using the mantra, put the power up 1 becomes 0, divide by the, oh dear, what's the one thing we're not allowed to do? We're not allowed to divide by 0. So we know that this thing here, if we went down that path, is completely wrong. And if you, what that should prompt you to do is to go and look at the formula book, and the formula book will tell you that the integral of 1 over x is ln x. So in actual fact, we can do this all in one go. So here we go. So put the power up 1, so it becomes 4, and then divide by the new power. Put the power up 1 becomes 4, divide by the new power 4. Put the power up 1 becomes 3, divide by that new power 3. That was a power of 1. Put the power up 1 becomes 2, divide by that new power. When you're integrating a constant, so the integral of any constant with respect to x, you just throw an x in. So the integral of minus 1 becomes minus 1x. Formula book, the integral of 1 over x is ln x. And don't forget, when you're integrating, it's always a plus c at the end. Okay, part B, differentiating from first principles. In order to differentiate from first principles, you need differentiation from first principles formula. And you have to learn it. And there's the formula. Okay, so now you've got the formula, quote it, you will get marks. Then, of course, you have to be able to apply it. So f of x is 3x squared minus 5x plus 2. F of x plus h. Then what you have to do is you replace the x by x plus h, and you get this line. And then you expand it out. The working out is being done over here. I think this is a place where you do a little bit of work yourselves. And then when you've actually got to that point where you've expanded it all out, then you start bringing the problem together. F of x plus h is already written down. It's written down on this line here. You're going to be minusing f of x. So here you write down f of x. Now f of x is 3x squared. So I've written the 3x squared under the 3x squared. It's minus 5x. So I've written the minus 5x under the minus 5x. And it's plus 2. So I've written the plus 2 under the plus 2. Why did I do that? To make the minusing more easy. So when you do the minusing, 3x squared cancels, the minus 5x take away minus 5x, it cancels, the plus 2 take away cancels. So you're left with 6x, you're left with 6hx, you're left with 3h squared, and you're left with minus 5h. And then what does the formula tell you to do? Divide by h. So now you divide by h. Now this line, I think I skipped a line, so I'm going to go off to one side and do it here. So what I have is I'm going to have 6hx over h plus 3h squared over h minus 5h over h. And the h cancels with the h cancels with one of the h's, h cancels with the h. And that leaves you with 6 on x, which is what we have here. We've got a h left there, so it's 3h. The 2h is cancelled, we're left with minus 5. Now, you've got to remember for this that you must let h tend to 0, not equal to 0. But you, ironically, you do let it equal 0, but in the working out it must say tend to 0. As h tends to 0, 3h becomes 0, and the answer is 6x minus 5, which is written in there. And that's the end of that particular part of the problem.